Okay, let's keep looking at the types of radiation. So we've already looked at alpha decay, that makes an alpha particle, and we looked at beta decay, that makes a beta particle. The third type, the third most common type of radiation is, this is one that doesn't actually make a particle, it releases energy. And this is called gamma radiation. Sometimes it's called gamma waves or gamma rays as well. So we'll still call it gamma decay, but the type of energy that we're making is a gamma ray. So this type of radioactive decay, it happens when we still have an unstable nucleus again. So whatever this isotope is, here we've got cobalt 60. This nucleus is unstable, but it's at, we call it a high energy. Just like, high energy. Just like when you've got a lot of energy and you're jumping around and bouncing off the walls, a nucleus that's got a lot of energy, it's vibrating and moving a lot, and it needs to get rid of that energy somehow. And the way it does that is by giving off a gamma ray. So, we've mentioned gamma rays are a type of energy, and actually they're a type of light. And we've actually come across them before when we learnt about light back in the physics topic. So remember, light, it can be just visible light, but remember there are lots of other forms of light depending on the wavelength. We can have infrared light, we can have ultraviolet, X-rays, and we can also have gamma rays. So the proper name for this is electromagnetic radiation. Electromagnetic meaning light, and it's radiation. So these gamma rays, they get released by the high energy nucleus, but because it's just energy, it's not a particle, it doesn't actually weigh anything. So we started with cobalt 60 here, and it hasn't lost any mass, and it hasn't changed any protons or neutrons, so we're staying as the same element in the end. So the element stays the same. Often gamma decay happens at the same time as alpha or beta. So sometimes there is a mass change, but if there's just one gamma ray released, then we're not changing the element here. So that's the three main types of radiation. And the last thing to look at is how dangerous actually are all these. Because we've probably all heard about radiation being dangerous. You might have heard or read a lot about the Chernobyl disaster, which was the power plant in Ukraine. And you would have heard about nuclear weapons as well. And these are all dangerous because of radiation. And really, radiation is dangerous because of energy. And here's the energy level of the three different types of radiation here. Alpha particles, they have a pretty low energy. They fly through space, and as soon as they hit any kind of material, like paper, or just clothing, or the skin of your body, they'll get stopped, and they won't do any damage. So, alpha particles are not dangerous, because they don't have much energy. Beta particles, they're a little bit higher in energy. You can say medium energy. And they'll go through paper, but they'll get stopped by a thin sheet of aluminium metal. So like tin foil from the kitchen. So they can actually go through your skin into your body, so they can be dangerous a little bit. But the really dangerous type of radiation, and this is the one that we've all heard in popular culture, this is what comes from nuclear weapons. Gamma radiation is the dangerous one. So it's a really high energy form of light. So high energy that it will fly straight through paper, through aluminium. Even if you had a really dense material like lead or concrete is also needed. Even some of it will get through lead, so you need to use a really thick layer of lead or concrete. And this is what they built all the bunkers and the structures out of when we had the Cold War, which is in the 20th century, and countries were worried that there'd be a nuclear war. So they built lots of bunkers and structures with really thick walls of concrete and lead, so that people could hopefully be protected from gamma radiation if any nuclear weapons went off nearby. So that's the three main types of radiation that atoms can undergo. There are other types, but we'll stick with these three for now.